Salam Jawano. Let's have a look at this ATP paper. This is the first question. A student investigates the resistance of a diode when different currents flow through it, and for that, these two terminals are open. He's going to connect different things in X and Y to see what happens. First, they've asked you to draw the symbol for a voltmeter to measure the potential difference across the diode. This is your voltmeter. Now, the student connects a connecting lead, like a simple wire, between X and Y, closes the switch, records the voltmeter and the current reading. These are the meters as shown. Now you have to record the reading in 1.2 in the top row. So top row, resistance between X and Y is 0 because it's a simple wire connecting lead. So there's no resistance. The voltmeter reading, be careful over here. This is 0.2, 0.4, 0.6, 0.8 and 1. Now, between 0.8 and 1, the difference is calculated by doing 1 minus 0.8. And there are how many divisions? 1, 2, 3, 4, 5 divisions. So each small division represents 0.04. Don't make the mistake of assuming yourself that it is 0.02. Because if you assume it is 0.02, then this won't be 1. This will be 0.9. But this is 1. So the easiest way is just note two readings, take the difference, divide by the number of gaps, so that you don't mess up on the easy marks. The smallest division is 0.04, and this needle is in the middle, so it's going to represent 0.02. So the reading on the voltmeter is going to be 0.82, and the ammeter reading, this is 0, this is 1, so this is 0.1, 0.2, 0.3, and then this is 0.35, 0.3, and 0.4. 10 divisions, each represents 0.01, so 0.35. Now, calculate the resistance. You calculate the resistance using the formula. The student connects a 3.3 ohm resistor between terminals X and Y as shown. These are the readings. Closes the switch, does all of this, repeats the process for 6.8 and 10 ohms. So they've given you some values, some you had to calculate. You've done that. Now, as the resistance between terminals X and Y change, the current in the circuit changes. Examine the results in table 1.1. Describe how the changes in the current affect the voltage across the diode. So you have to look at the change in the current and how that affects the voltage across the diode. If you look at the change in the current is decreasing. And what is happening to the voltmeter reading? It's almost constant, 0.82, 0.82, 0.81. You can say the voltmeter is decreasing, reading is decreasing. You can also say it's not changing. It's almost the same. It's almost constant. So as the current decreases, that's the change in current. The voltage across the diode does not change, or you can also say the voltage across the diode decreases slightly. Describe how the change in current affects the resistance of the diode. So again, the current is decreasing. So what's happening to the resistance of the diode? The resistance of the diode is clearly increasing. So the resistance of the diode increases. The student sets up the circuit using the diagram figure 1.1, finds out when the connecting lead is connected across terminals X and Y, and the switch is closed, the ammeter does not give a reading, the ammeter is not broken. What is the reason that the student is not getting an answer? It's because you've connected the diode in the reverse way, or in the opposite direction, such that it is reverse bias, it's not forward bias. So if you connect your diode like this, where the positive is connected to N, now even if this ammeter is not broken, it will not show you any reading because it won't allow current to pass through. So you have to think of that the diode has been reversed, so it is not allowing current to flow. Question number 2. The student investigates the rate of cooling of hot water in a test tube under different conditions. So you have a test tube, you pour 200 cm cube of cold water into the beaker. There's another beaker like this one. And in the test tube, you pour hot water until it is approximately 1/3 full. He lowers the test tube into the beaker of cold water. So he lowers it into this cold water, and actually what's going to happen? It is going to start flowing out. Waits for approximately 30 seconds before measuring the temperature and starting a stopwatch. So he places the thermometer inside the test tube. Now, the first question is, this is the reading in figure 2.3. Read the thermometer and record temperatures in table 2.1 at time t0. So this is your initial reading. So this is the initial temperature of the hot water. You can clearly see this is 70. Again, don't mess up on the divisions. 70 and 80, 10 divisions. So this is going to be 73, 73. Degree Celsius, and seconds. Time was in seconds. They mentioned it over here, 30 seconds. Now, after 30 seconds, you have to fill up this table. So intervals of 30, 30, 60, 90, all the way till 180. This is how the temperature is dropping in the cold water beaker. After 30 seconds, the temperature drops to 54, 60, and you can see the trend. Now, the student measures the temperature theta. Complete the column headings, you've done that. Complete the time column, you've done that. Describe in detail one precaution the student must take to make sure the temperature measurements are as accurate as possible. Now, over here, multiple people will make a mistake, and that's exactly what I want to clarify. The mistake that a lot of people will make is that they'll say, wait for the reading to stabilize. Because that's what you usually write when you're noting temperature, you wait for the reading to stabilize. No, you write that when you're doing heating experiments. When the temperature is rising, you've heated something up and you want to know what is the final temperature of that thing, you have to wait for the temperature to stabilize. So when you're measuring the final temperature of water heated by an immersion heater, you've done multiple questions with me like this in your past papers. Why wait? You need to allow time for the temperature to rise and level off before noting the final value. So for this, the valid precaution is wait for the thermometer reading to stabilize. Another example is Ohm's law. If you're measuring voltage and current, you know that the voltage and current will vary. So you have to wait for a moment for the voltmeter and ammeter reading like this one. You have to wait for a moment for these arrows to settle down, because if they're fluctuating, then the reading that you will get is wrong. That does not apply to this question, because in here, the question is that the temperature is dropping. So you can't wait for it to stabilize. In fact, you have to take the readings very quickly. In this experiment, the experiment is about how fast the temperature decreases over time. So that precaution cannot be used. Here, the precaution should be that your eye level must be in line with the reading so that there's no parallax error. So read the thermometer scale at right angles or the eye level. The student repeats the process, but with 200 centimeters of hot water or warm water. And that is this column over here, which gives you this trend. Now, one of the students' readings for warm water recorded in figure 2.1 is anomalous. Anomalous means something which is not following the trend. So let's go to the warm water and let's look at the readings. The reading should fall. The reading is falling. It's falling. And you can see that's kind of following a trend. Suddenly it drops too much. So here the trend is broken. And then the temperature rises. So actually, if you think, this reading is the problem, because it can't drop suddenly in 30 seconds from 55 to 30. That's like a 20 degrees Celsius drop. Here the temperature drop is 3. It's all of these temperature drops are very small. How can suddenly the temperature drop be 20? So that is your anomaly. Actually, I think this reading should have been 53. Maybe he wrote it the wrong way. That's also possible. Rather than writing it as 35, he may ended up writing it as 53. And that is why there's a big jump here. And that is why there's another big jump over here. So the question is, what is your anomalous reading? Anomalous reading is 35. It is not following the trend because the next reading is much higher. The next reading is 53. How can the next reading is actually 52? How can the next reading be high? You're losing heat. You're not gaining. So that was one reason. The other way you could say is, it is you figured it was anomalous because this drop was too big. The drop in temperature was too high. So that's also one way. Possible reason, parallax error. Possible reason, maybe the temperature was written wrongly. That could also be one of the reasons. Temperature was written wrongly. So use your temperature readings in table 2.1 to calculate the temperature decrease of the hot water in the test tube after cooling for 180 seconds. So the temperature drop in the cold water was 39. You calculated this by subtracting this from this, and in the hot water, warm water, 75 minus 52. Make sure that you give it in the right places. So this is the 39. Make sure you give the units. If the units are not given, you have to write the bare numbers. Don't give you answers. Use your answers to D2 to decide how the temperature of the water in the beaker affects the rate of cooling of hot water in the test tube. So the rate of cooling, first you need to understand rate. Rate means anything which is divided by time. Now rate of cooling means the temperature drop divided by time. You know that the time is 180 seconds. You've calculated the temperature drop already. For the cold water, the temperature drop was 39. For hot water, it was 23. So you've calculated the rate of cooling. Now they're saying use your answers to decide how the temperature of water affects the rate of cooling. I think it's pretty clear. You just have to state your conclusion. You don't have to give any reason. Just state your conclusion. No reasoning required. So the rate of cooling, is it higher or lower in the cold water? Look at this 0.216 and look at this 0.128. In hot water, the rate of cooling is lower. In cold water, the rate of cooling is quicker. So in cold water, the rate of cooling is faster. Mostly in paper 4, they're asking you to state, mostly, by looking at the data. They never ask you to justify the answer. Mostly they don't, unless it's not paper 2 or let's say for IGCSE. For IGCSE, paper 4, for O-level paper 2, that's where they ask you to explain. When they ask you to explain, you have to undergo the reasoning. When they ask you to state, you just have to look at the trend, and paper 4 is mostly about looking at trends. So suggest one improvement to the experimental procedure in A and B that allows for a more valid comparison to be made at the rates of cooling. So whenever it's a heating experiment, you have to ensure that the beakers are lagged. So this warm water beaker, this should be lagged. Lagging should be done. So heat losses to the surroundings can be prevented so that your results can be accurate. So lagging thermal insulation of the beaker to avoid heat gain or loss from the surroundings. The next question. A student investigates the balancing of a meter rule. Very common. How do you ensure or how do you find the position of the center of the 50-gram mass on the ruler? This is a 50-gram mass. You want to find out the center of this. So where is it? It's starting from here and ending here. So it's at 93.5 over here. It's at 95.9 over here. You want to find the position of the center. You're not being asked to find the diameter. You're being asked to find the position. So it has to be somewhere in the 90s. So you have to find the middle value of these two. So the middle value will be 94.7. All right. It's centered at that position. Calculate the distance d from the center of the 50-gram mass to the 50 centimeter mark. So from the center of this is at 94.7. So let's say this is at the 94.7 mark. This is at the 50 mark. What's the distance d? Just subtract them. We'll get 44.7 centimeters. Now, calculate the value of 1000 over d. Just do 1000 over d and you will end up getting as your answer as 22.371. Let me just do it again. 1000 divided by 44.7. Yeah, 22.371. Record your answers on this line. Please make sure record your answer on this line, in the answer line, and in the table. So when you're giving it here, oops, 1 second. When you're giving it here, your answer should be 22.37. This is the answer on the answer line. But when you're giving it in the table, let's have a look at the table. In the table, you have to make sure that down the column, your number of decimal places are the same. So 22.4 is what you write over here. All right. Now, question. It is difficult to balance the rule exactly. They're giving you the scenario over here. That this rule, it is very difficult to balance it exactly. When you will place this, it will topple. Maybe it goes this way, maybe it goes that way. You know, when you try balancing this pen, you put something here, maybe it goes down. Maybe if this is too close, maybe this side goes up. They're giving you the scenario. It is difficult to balance the ruler exactly. Describe a technique that the student uses to make sure that the value of D is as accurate as possible. You have to look at this scenario. Now, if somebody says that you should use a thread to suspend this mass, do you think by adding a thread, you will be able to balance it accurately? No, you won't. It will still topple. It is very difficult. That's what they're saying. Look at the difference in the question. When do you use a thread and the mass is attached? That is when you want to accurately find the location. When you accurately want to find the position, they're not asking you to tell us how do you accurately find the position of the center. What are they asking you? The question is saying, describe a technique that the student uses to make sure that the value of D is as accurate as possible, move the load slowly until the ruler tilts one way. So move it slowly until the ruler tilts this way. Now you know that you're too far from the pivot. Now you move it backwards, slightly back until it tilts the other way. Now use the midpoint between these 2 points to find the balance point. Do you understand? Using a thread to suspend the mass, it improves the precision, it improves in finding the exact point, but that is not what they wanted. Ensuring that the load is centered at a particular point. In those cases, if they say, how do we ensure that the load is centered at a particular point? To find the center, and now imagine you have this. It is difficult to find the center that you can't read off from here. The ruler is blocked. In that case, what helps is use a thread to make sure that it is centered properly. Got it? But if the question is describe a technique and they've given you this scenario, you have to understand the scenario. If they didn't give you the scenario, then you could have mentioned, but they've given you the scenario, therefore your answer has to be proper, which means you have to think of that scenario. If you're able to think of that scenario on exam day, you will be easily scoring in these questions, inshallah. Actually 1 mark, so don't worry too much. So actually the uncertainty in D is coming from not knowing the exact balance point. And to find the exact balance point, first you need to balance it. First you need to find out at which point does it balance. Now, if they ask you how to determine that position very accurately, use a thread. All right, next, they've given you this table. You figured the distance and the 1000 over D value. Next, they ask you on the grid provided in figure 3.3, you have to plot a graph of mass M on the y-axis against mass M should be on the y-axis. So this is on the y-axis. Usually, the first column is X, but now they're saying this should be Y. So write a big Y over here, so you don't make that mistake. And put a big X over here, so you don't make that mistake. And the axis does not need to start from the origin, so you're free. And you should not, because you know you should have covered 3/4 of the graph. So your x-axis values are from 50 to 100. So do you need to start from 0? No. Your y-axis values are from 50 to 100. So does your y-axis start from 0? No. You just need to cover the full axis. I'll show you. Look over here. I started from 40. So this was 50, took in differences of 10. 100 was over here. Beautiful, beautiful scale. And quickly wrote M over here. Then on the x-axis, if you look, I need to go from 22.4 to 45. Now, I tried different variants of this. I started writing 20 over here. Then I said, okay, this is 40, 30. Then this is going to be 40 boxes of 2. And then this is going to be 50. So 45 is going to be here. But this, if I stop here, this does not cover 3/4 of the graph. 3/4 of the graph should be at least till here. At least. At least. So look at this. 1, 2, 3, 4, 5, 6, 7, 8. 8 boxes. 8 boxes. You need to cover 3/4 of the graph. So that means 6 boxes have to be covered. So if I started with 20 over here, 30, 40, and this is 45. How many boxes have I covered? 1, 2, 3, 4, 5. I have not covered enough boxes. I need to be at least till here to cover 3/4. Y-axis I'm sorted because my last value is 100 in the table. My last value is 100, and in my graph, the last value is 100. 100 I'm sorted. I need to be sorted horizontally. So what I did was I started from 10. So took this as 10, 20, 30, 40, and I knew that that would automatically shift the last value over here, which would solve my problem because the last value was somewhere around 45. There we go. Then I carefully plotted all of the values. As you can see from this plot, this is one value, this is one value. When you're doing this, try to use the same scale and figure out these values and just try to write down the values on the x-axis as well. So there's 20, this is 30, this is 40, this is 50, and wherever you're plotting, so let's say this is the value called 39.5 because this is 10, this is 20, so this is going to be 11 and this is going to be 10.5, 11, 12, 13. you can think about it, 10 and 20. So this should be 15. Now between 15 and 20, how do you go from 15 to 20? 16, 17, 18, 19, and 20. So that's how you know it's boxes of 2. So this value over here is going to be 31. This value over here is going to be 35.5. So check karo table mein. 31, 35.5. All right. And on the y axis, I think it's pretty straightforward because this is 40, this is 15, this is 20 boxes. So this is again 41, 42. So 100 is very clear, 90 is very clear, 80 is very clear, 70 is very clear, 60 is very clear, and 50, is there any reading on 50? Yes, there's a reading here. I can see it from here. This is the reading, but it wasn't 50 actually. So for 50, it was actually 22.4. So if I go here, let me show you. This is 20, 21, 22, 23. Now, this reading over here is 22.5. It said 22.4, so therefore you can see it's clearly slightly behind. And at this value, the y-axis value is 50. Here you go. So that explains my graph. Now, once you've drawn your graph, draw a beautiful best fit line. Look at my best fit line. All of the points are not on the line, and that's exactly what the whole point of the best fit line is. You should have all points very close to the line. Remember, even if a point is here, it is still going to be a best fit line. A lot of kids make this mistake. They call this as anomaly. This is not an anomaly. Anomaly means if a point is not following the trend. Like you saw, there was a temperature drop. Suddenly, there was a drop of 20, when the drop was supposed to be between 3 and 5 degrees. So if something is here, that means something is anomalous. And if in case you're getting an anomaly, please make sure you double check it. Otherwise, that means you've made a mistake. Now, you draw the straight line of best fit, calculate the gradient of your line, show all of your work in, indicate on the graph the values used. Due to this thing, first thing I always do is I write the coordinates and I make sure that I'm writing x and y properly. A lot of kids make this mistake, writing x and y wrongly, writing y first and then x. I don't know, exam day, anything can happen. You're very well equipped to be very creative, but please make sure your mind is working. For that, sleep on time. Number one. Number two, what I did was, and this is what you should do if they ever ask you, you should always write the coordinates for them very clearly so the examiner knows what points you've taken. The points must be at least half the line apart. So that's one thing I ensured, the points are half the line apart. And if you notice, I picked up points which are in the table. I don't want to mess up, and I didn't want to put in extra effort as well. भाई अगर क्लियरली नजर आ रहा है कि 2 पॉइंट्स आपके लाइन के ऊपर हैं और वो टेबल में मौजूद है, तो आपको एक्स्ट्रा एफर्ट करने की कोई जरूरत ही नहीं है, आप वही पॉइंट्स उठाएं. So that's exactly what I did. I picked up points on the table. I made sure that they at least have the line apart, and then I just created havoc by finding the gradient from those points. Good havoc. And 80 minus 50 divided by y2 minus y1 or x2 minus x1. I found the gradient to be 2.3. It's in the range. Found the mass value by multiplying this. Got the answer. Why this method of turning m of the fixed load is unsuitable if a movable load of mass 40 grams is used. Now, this is where you have to think. So they're saying why this method of determining m is unsuitable if a load of 40 grams is used. If you're using a 50 gram load, the distance from the pivot is 44. You have to understand this. This is where your mind has to work. Go back and read your experiment again. When the mass is 50, the distance is what is distance d? They asked you to calculate distance d, right? Distance d is the distance from the center. So the distance on the center, where is the center? The center is already at 50. And distance d is 44.7. That means that the position of this 50 gram mass is 94.7. Now just imagine. A 50 gram mass is probably balancing over here at the 94.7 centimeter mark. This is where your knowledge comes. If you use a lighter mass and you have to balance, won't you have to move it further ahead? Now imagine if you have a 40 gram mass, do you think it will balance? वो तो ruler से आगे निकल जाएगा. So that is the question. They were asking you to think of this little point. So the mass would be unable to balance as the required D would be larger than 50 centimeters. The D, the gap from the center to the point where the mass could balance, would be larger than 50. The ruler will not be enough. Basically, even if you put it at the end, the mass would not balance. You just have to give the examiner the point across. You don't need to exactly have the same words. Never. You don't know the English that they've written. You should have the words which give the same effect. If that is the case, you will get the mark. So that was this question. And now question number 4. The student has a converging lens and needs to determine its focal length. Plan an experiment. So plan an experiment that will enable the student to measure accurately the value of the focal length. They've given you the formula for the focal length. Now this is, again, you need to use your knowledge of light. This is the object. This is the triangular object in which you've put a piece. You've put some holes so that light can pass through. When light passes through, naturally it's going to pass through a lens. What do you need over here? You need a mirror. You need a screen to capture the image. And you know, in order to measure focal length correctly, you need to move the lens so that a focused, sharp image, the image will actually also be inverted. That's something that you should know. If the triangle piece is like this, after passing through the lens, it's going to be inverted. So on the screen, you need to have an image. And you know, if you can capture an image on a screen, which from real rays, the real rays will converge and meet on the screen. So this is a real image or a virtual image? It's a real image. All real images are inverted. That's something in your head. So yeah, so you have to write an experiment to simply find out what the focal length is. For that, they explained U is the object distance, V is the image distance. Now, always remember, you just have to answer these questions. List an additional apparatus, any additional apparatus you need. I need to measure the lengths because I need U and V. I need a screen to capture the image. That's it. That's the additional apparatus. Draw a diagram. So here we go. Bench, I've literally, you should also literally copy it, and you don't have to be very artistic. You can just do it like this. So this is your card, this is your lamp, this is your lens in the holder, and this is the screen. If you notice, I haven't made any rays either because they're not asking you to make rays. It's not a paper 2 question, or it's not a theory question. It's actually a question for designing an experiment. So I'm more concerned about the experiment. How will I write down the experiment? So what I'll do is I'll say, and just look at this, I'm going to answer these questions and I'll get full credit, inshallah. A meter rule and a screen are needed additionally. The screen will capture the image of the triangular object. The screen will capture. The meter rule will be used to measure the image distance, which is V. The distance from the mirror to the center of the lens. I could have written V as well over here. And the object distance from, you have to explain because they did not explain what is object distance, what is image distance. They just said that you have to measure U and V. So you're explaining a distance from the object to the middle of the lens. That's the object distance. Most important point, the lens has to be moved until a sharp image of the object is formed on the screen. Then the image and object distance are measured. You substitute these values of U and V and you get F. That was the question. Look at this. How to do the experiment? We said you have to move the lens until a sharp focus image is formed. And we also said that then once you figure out U and V with the help of the meter rule, and we've explained how will you measure U, how will you measure V, just explain how to use your readings to find F, substitute. They're not asking you for anything else. You get full marks. Literally, this is the experiment. Now, another variant of this question in which you had to think a bit is this one. Look at the similarity. Student investigates the effect of changing the color of light on the focal length of lens. Notice the formula is the same. Now they're saying that we'll pass different colors through the lens, and how does that change the focal length? Naturally, that will change the focal length. U is the distance again, V is the distance of the image and the lens. Plan an experiment to investigate the effect of changing the color of light on the focal length of a lens. The following apparatus is available: an illuminated object, a selection of colored filters, converging lens, screen, meter rule. Do you have an idea now? Think. Pause the video and think now. And try to answer these questions. So they've given you this list. Other normal apparatus is available. In your plan, you should draw a label diagram to show the arrangement of the. Have you understood the question? The question is very simple. You're changing the color, and by changing the color, naturally the focused image will shift if you change the color. You have to measure the focal length. So do you need to adjust your lens every time to find that perfect focused image for each color? Yes, that's the experiment. Literally, look at this. Now, because they've already said that you're using an illuminated object, so that eliminates the need of a lamp. Otherwise, if you had said, I need a lamp, I need this object with holes, perfect. That also works. This is together, this is called an illuminated object. So this is your illuminated object. This is your filter, red color, green color, blue color. You put a filter, and that filter has to be in a holder. Obviously, you can't be holding it with your hand because you need to take measurements. Lens holder. I should have labeled lens and lens holder. I'll do that right now. The lens. This is the lens holder. And this is the screen. Now, draw a label diagram. Done. Explain briefly how you would do the investigation. So what are we changing? We're going to change the filter. And due to the filter, the screen, the image will sometimes be focused, sometimes not. Do we have to make sure that for each filter, when the image is formed, should the image be focused on the screen? Yes. Let's start. So the answer is literally the same, but the order has changed because the way they're asking you, that's exactly how you're supposed to answer. Start by this, then go to this, then go to this, then go to this. So I'm starting with explain briefly how you would do the investigation. So light passes through the filter and the lens. So light will pass from the illuminated object. You can say light from the illuminated object passes through the filter first and the lens and is incident on the screen. The screen will capture the image of the illuminated object, and you know that the image is going to, let's say you're using a triangular object, the image is going to be inverted, just for your knowledge. The lens is moved until a sharp focused image is formed on the screen. You know that. The meter rule will be used to measure the image distance. Again, you've explained what is image distance. And object distance. Again, you've explained what is object distance. Then the image and object distance have to be measured. Substitute the values of u and v into the equation and find f. They did not ask you to tell us what measurements you will take. So you've taken the measurement of u, you've taken the measurement of v, and find out f. Because you need to find a relationship between, the question said, you have to find a relationship between the effect of changing the color on the focal length. So we have to get f. Now, the experiment is repeated by changing the filter. This is what you need to tell them. Because when you're making a table, you need multiple readings. So how will you continue? You would change the filter. Again, move the lens until a sharp image is formed on the screen. And that's it. Repeat the steps. Experiment is repeated by changing the filter. The lens is readjusted to develop a sharp image on the screen. And then the readings are taken. So color, U, V, F. At least 5 sets of readings are taken and a bar chart. Now remember, if you have something which you can't quantify, like color, you can't give a value to it because the question did not tell you. If you were in A levels, you would have known what we could have done here. But because you're in O levels, they will not expect you to it. So what do you do when you have one axis which you cannot quantify? You always make a bar chart. Bar chart में पता क्या होगा? यहाँ पे color आ जाएगा और यहाँ पे उस आप frequency axis ले आओगे. So यहाँ पे you will have color. You don't have to make this graph. This is just for your understanding. So red, green, blue, violet, blah blah blah. So for red, this was the focal length. You have a point. For green, this was the focal length. For blue, this was the focal length. So and so forth. So at least 5 sets of reading are taken. And if you have one axis which you can't put numbers on, then what you do is you put a bar chart. A bar chart is plotted with the color versus the focal length. The trend of the bar chart will show the relationship. That's it. They asked you to state how you would use your results to reach a conclusion. They're not asking you for the conclusion. So don't give them a conclusion that if you're using red filter, the focal length will be more. If you're using a blue filter. No, they're not asking you for that. They're just asking you how. And the answer is always by using the graph, and the trend of the graph is going to show that relationship always. All right. All the best, guys.